I'm Anil Kumar. Welcome to my series on providing you with solutions from Cambridge International Examination test papers. The idea here is to understand how to solve these questions and perform better. So in this particular video, we'll combine few questions which are related to trigonometry. Here is question number 5 from one of previous papers of 2017. Let us see how to solve this kind of question. Express 2 cosine theta plus square root of 5 sine theta in terms of r cos theta minus alpha, where r is greater than 0 and alpha is between 0 to 90 degrees. Giving the value of alpha correct to 2 decimal places. Now this is a very standard question and is asked in many test papers. Let us try to understand this strategy. So what we are given here is 2 cosine theta plus square root of 5 sine theta. Now we need to write as one particular function, which is cos theta minus alpha. So the formula, if you work backwards, think like this. So thinking portion, let me show you in a different ink so that you understand the strategy which we are going to adopt. So if you look into this particular right side, we are saying we want to make it equal to r of cos theta minus alpha, right? That is r of, if we expand this, we get cos theta cos alpha plus sine theta sine alpha, correct? So r outside, right? So we are looking for the values of cos alpha and sine alpha. So if you compare this, then 2 and square root 5 can give you some idea. So what we normally do is we find the value of r as, we find this value of r as equal to magnitude of these two, right? Which is square root of 2 square plus square root 5 square. So what we get here is 2 square is 4, square root 5 square is 5, and what we get here is square root of 9 equals to 3. So we get the value of r as 3. Now, if I take 3 common in our equation, then what happens? See, if I take 3 common, then I could write this as 2 over 3 of cos theta plus square root 5 over 3 of sine theta. Does make sense to you, right? So that really shows that cos alpha and sine alpha could have a value 2 over 3 and square root 5 over 3. Perfect. So from here you can correlate that r is equal to 3, that is the value of r. And now let's work on cos alpha. So we are looking for cos alpha equals to 2 over 3 and sine alpha as equals to square root of 5 over 3. To get the value of alpha, we will divide one by the other. That is to say, sine alpha by cos alpha is equal to what? Is tan alpha, right? Which is tan alpha will be equal to square root of 5 over 3 divided by 2 over 3. So that is square root 5 over 3, right? So we get alpha as tan inverse of square root 5 over 2, correct? So that is how we can get the value of alpha, right? Now look here. So on this side, we could write this as, it's better to write this as cos theta cos of alpha, where alpha is 2 over 3, plus we'll write sine theta sine of alpha, and that could be written as 3 times cos of theta minus alpha, right? So we got what we really needed. Here we can now compare and we can write what alpha is. So alpha is tan inverse of square root 5 over 2. So shift tan inverse square root 5 divide by 2 is equal to So that is equals to 48.189, which can be approximately as 48.2 degrees. Okay. So no, we have to find alpha correct to two decimal places. So sorry, two decimal places. So we'll write this as 48.19 degrees. Correct. So that is how we'll do it, right? So we got our answer, which is R is equal to 3 and alpha is equal to 48.19 degrees. Clear? So that is how we'll solve it. Now to this question, we have part 2, which is hence solve the equation 2 cos theta plus square root 5 sin theta equals to 1 within the interval 0 to 360 degrees, right? So we just found that 2 cos of theta plus square root of 5 sin theta, we want to show it equal to 1, but we know the left hand side is basically equal to 3 times cos of theta minus, we'll write to two decimal places alpha value, which is 48.19, correct, equals to 1, correct. So here let me write down the answer clearly as 3 times cos of theta minus 48.19 degrees. Clear? Okay. Now, as far as cos theta is concerned, within the interval 0 to 360 degrees, cos is 1 at theta equals to 0 and 360 degrees, right? So, but well, here we have, let me rewrite this. So we have cos of theta minus 48.19 equals to 1 over 3. So we will have cosine as positive in two quadrants, right? So we have two solutions. Let's find alpha, and then we'll get this alpha. This is minus alpha, correct? Or we'll go like this. So this will be 360 minus alpha. Minus alpha, correct? So these are the two solutions which we are looking for. So let's figure out. We have shift cos inverse of 1 divided by 3. So that gives us 70.528. So we get two possible answers. So we get theta minus 48.19 as two values. One of them is 70.528, right? The other one will be 360 minus this, right? So the other one will be 360 minus our answer, which is 70.528. So we get 289.471, correct? So these are the two values which are for, we can say, theta minus 48.19, clear? So that means we have theta value as equal to, we can write theta as equal to two answers, 70.528 plus 48.19, or we have 289.47 plus 48.19, right? So let's add this up. So you can add this to 48.19. You get one answer as 337. Now this answer, they're not specified, so we'll just go for one decimal place, degrees, and the other one is 528 plus 48.19, which is equal to 118.72. So which is equals to 118.7. Right. So we'll just keep it to one decimal. We can write two decimal places also, right? So that is how we are going to answer this particular question. Correct. The other one, it is, let's rewrite this, 289.47 plus 48.19 to two decimal places, 337.66, right? So we'll write this as 67 degrees, correct? So these are the two answers. So we have our answer that theta is equals to 118.72 degrees or 337.67 degrees, correct? So I hope these steps are absolutely clear. This is called the wave equation. So I'll provide you with links on wave equation. Plus, in this video, we'll also add some other videos based on trigonometry, which have been asked in Cambridge International Examination earlier. Hope that helps. Feel free to write a comment, share your views, and if you have any doubts, you can always send email to the address given here. Thanks for your time and all the best.